Off lecture. Learn beyond class.
Hi friends and welcome to Off Lecture, Learn Beyond Class. And this is chapter 1, Patterns in Mathematics. Now comes another type of problem, okay, which is term to term rules, okay. Then we will understand position to term rules. So every rule we have written so far says the same kind of thing, how to get one term to the next. This is called term to term, term to term rules, okay. And it does not have to add. Take 5,000, let's say we take 5,000, okay. If we divide it by 10, we will get 500. If we again divide it by 10, we will get 50. If we again divide it by 10, we will get 5. So this is also a sequence. Now here is a problem. Look at 4. I'm writing 4, 8, 12, 16. I want the 50th term. I want 50th term. How would you get it? Wait for it, think about it, and tell me what should be the answer. Hmm, most people say keep adding 4. Okay, keep adding 4, 4, 8, 12, 16. Then we'll add 4, we'll get 20. Then we'll add 4, we'll get 24. But we have to keep on doing this 49 times. Long, boring, and you will slip somewhere in the middle. There are chances that you will make mistakes somewhere in the middle. So look at the sequence differently. Position 1 holds 4. Yes. Position 2 holds 8. Yes. Position 3 holds 12. What in each term compares to its position? 4 times the position. So this position is position 1, this position is position 2, this position is position 3, and this position is position 4. If we multiply it by 4, we will get these numbers. We will get these numbers. So if someone is asking me what will be the number at 50th position, so what we have to do is we have to just multiply it by 4 and we will get the 50th term in this series. That will be 4 times 50 is equals to 200. Okay. So what is each term compared to its position? 4 times the position. So 58 times is 50 times 4, which is 200. A single step and we got my answer. And that is known as position to term rule. And it links the position number straight to the value. सो ध्यान देने की बात ये है कि हमने किया क्या, सीक्वेंस वही थी, नंबर्स वही थे, बस हमने उस साइड से देखना छोड़ दिया, ऊपर से देखा कि पोजीशन के साथ, और जवाब 49 स्टेप की जगह एक स्टेप में आ गया। तो दो टाइप के रूल्स होते हैं, टर्म टू टर्म, एक एक कदम चलता है, एंड सीधी चढ़ना, जैसे जैसे हम सीढ़ी चढ़ते हैं वैसे, एंड देन पोजीशन टू टर्म रूल्स, डायरेक्ट सीधा छलांग लगाते हैं हम, जैसे लिफ्ट होता है। ओके, दोनों ऊपर ले जाते हैं, पर एक स्लोली ले जाता है और एक जल्दी ले जाता है। ठीक है, so this is known as term to term rules and position to term rules. So what is written here, you can read also. A term to term rules tells you what to do to the next, to the one term, to reach to the next. It can be either of the four operations. You may add, you may subtract, you may multiply, divide, not simply add. Okay, examples can be start at 9 and add 5. So you will get the terms like this: 9 plus 5 is 14, 14 plus 5 is 19, 19 plus 5 is 24. But when we have to identify 100th term or 58th term, then we use position to term rules. Okay, and this is what I have explained here, like position to term rules, just straight to any term you want. The term to term rule cannot give you 50th term without all 49 before it, because term to term rule just give you the next term from the current term. Okay. A position to term rule links the position number directly to the term. So for example, when we were talking about 4, 8, 12, 16, the rule is to multiply the position with the 4. So 25th term will be 25 into 4, that's 100. And 50th term will be 50 multiplied by 4, that is 200. Okay. So position number to term is giving you the answer in one step. Now you can test it. We have a sequence 2, 4, 6, 8, 10. Find the term to term rule, the position to term rule, and the 50th term. This is the question from the Cambridge book, that is the book that is used in international boards and the ICSE boards. So what can be the model answer for it? So to identify the term to term rule, we are adding 2 each time. So after 10 comes 12. If you see 2, 4, 6, 8, 10, we are adding plus 2 every time. So for next term, we will add plus 2, we will get 12. Now you can table it like 2, 4, 6, 8, 10, and 12. And at position 1, we have 2. At position 2, we have 3. At position 3, we have 6. At 4, we have 8. At 5, we have 10. And at 6, we have 12. So here we are writing the positions. And here we are writing the numbers of our sequence. So what position to term will give you? Every term is its position multiplied by 2. That is, if you multiply this position by 2 with 2, you will get your number. 2 multiplied by 2 is 4, 2 multiplied by 3 is 6, 2 multiplied by 4 is 8, and so on. So if we want to calculate the 50th term, we have to multiply it by 2 and we will get 100. So without listing every term in between, we can directly jump to 50th term. Okay. So now we will understand formulas and building things, that is patterns you can build using matchsticks, dots, and tiles. Okay, there are some sequences that have formulas ready-made, and there are 4 sequences for which the formulas are worth knowing. That is nth odd number. The nth odd number, the formula to calculate nth odd number is 2n minus 1. Okay, so the 10th odd number is, if we put 10 in place of n, 2 times 10 is 20, minus 1 is 19. So 10th odd number is 19th. Similarly, nth even number is 2 times n. So 10th even number will be 20. Okay. Then comes nth square number. Nth square number is n times n, which is n square. And then comes nth triangular number. Triangular number, which is n times n plus 1 by 2. Or you can simply write n plus 1 by 2. So seventh triangular number will be 7 times 8 by 2. That is 28. Okay, seventh triangular number is 28. But can you trust any formula? What should you do? I have given the formulas for some particular series, some important series, but do you trust these formulas? To build the trust, what you have to do is you have to test it on the term you already know. That is, check the seventh triangular number by adding 1 to 7. You will get 28. Now the formula has earned your trust. For example, if we do or if we calculate the seventh triangular number by simply the pattern we know, that is 1 plus 2 is 3, plus 3 is 6, plus 4 is 10, plus 5 is 15, plus 6 is 21, plus 7, sorry, plus 7 is 28. So 1, 2, 3, 4, 5, 6, 7. So seventh term in triangular series is 28. So this formula holds true. So फॉर्मूला को सिंपली लर्न नहीं करना है, पहले उसे एक छोटे टर्म पे टेस्ट करना है जो तुम्हें पहले से पता हो, जैसे जो तुमने पैटर्न बनाई है उस पे टेस्ट करना है। अगर मैच हो गया तो बाकी बड़े टर्म्स पर लगा के देखो, ठीक है। तो सिंपली आपको सही और गलत में फर्क पता चल जाएगा, ठीक है। एंड दिस वर्क्स विद ऑब्जेक्ट्स टू, नॉट जस्ट नंबर्स। बिल्ड अ रो ऑफ स्क्वायर्स यूजिंग 4 मैच स्टिक्स। द फर्स्ट स्क्वायर टेक्स 4. Each square after it shares a side with its neighbor, so it needs only 3 more. The count runs 4, 7, 13 like this. Okay, so you have to draw it, you have to table it, you have to rule it, and then you have to predict it. First you have to sketch the next two diagrams in the pattern. If you see, this is one pattern and this is second pattern. We have 2 matchsticks, then we added 3 matchsticks so that it touches both the 2 matchsticks, so we will get this pattern. Now if we have to add one more matchstick, we will get this pattern. Then if we want to add one more matchstick, we will get a pentagon. This will not be looking like this. This is a wrong figure. It will look like this, somewhat like this. Okay, so you have to sketch the diagrams, then you have to record the number against the counts, then you have to start the value and the step size, and then you have to use the rule to reach the 8th or the 50th diagram using the position to term rule. Position to term rule. Okay, now last question, and it catches everybody. Okay, we are moving towards the end of this session, so this is the last question for you. A farmer puts a post at 0 meters. Okay, then every 3 meters up to 30 meters. So how many posts he will add? Okay, the question is, a farmer puts a post at 0 meter. Okay, then every 3 meters. Okay, up to 30 meters. So how many posts he has used? Okay, and with this we are ending this session. The answer of this question will be in the next slide and next video, where we will go through all the NCERT solutions or all the NCERT problems along with their solutions. Okay, I will tell you the answer of this question in the next lecture. So a quick recap before we end this video. What is maths? Maths is the search for patterns and for why they exist. Both the things. First searching the pattern, then asking the why for it, then number sequences, ordered list built by one clear rule. It is a ordered list and built by one clear rule. Then pictures, dots explain why a sequence behave as it does. You can remember this with a triangular series. So with the help of the triangular series, we understood why the series got the name triangular. Then relations, odd numbers add up to squares and much more. We started with this question, like why the adding up of odd numbers is reaching to squares. So we understood how one pattern or one sequence is related to another sequence. Then we have shape sequences, which is the study of the shape sequences is known as geometry. So we understood polygons, graphs, check, matchsticks, and snowflakes. And then two rules, which is term to term steps along and position to term rule, which help us to give the jump and tell the any nth number from that pattern or sequence. So this is what we have completed in this video. In the next video, we will do all the NCERT problems, and then we will move further to get or to understand other problems from other books as well. As promised, we will be going through the Cambridge books, we will be going through the R.D. Sharma books, we will be going through the other IB books, and from that also we will understand how the questions will be built on this chapter. Okay, just before you leave, do one thing: take a notebook, put 36 dots on the page and make both the shapes, the triangle and the square, and do it by hand, and ask to yourself whether 36 is a triangular or a square shape. Okay, I'm not telling you it has 4 digits, so सही बताएंगे, अगली वीडियो में उसका नाम दूंगा. Thank you, bye bye.